Hi, in this tutorial, we're going to talk about coordinate systems. To make different effects, we have to use different coordinate systems. For convenience and ease, throughout this course, we have mainly used the UV coordinate system. This is the default coordinate system used to map the 3D coordinates of an object into 2D coordinates and apply the textures on it. It allows you to deform the coordinates in many different ways. For this reason, you can also use it for effects. For this, you have two UV channels that you can load from your 3D modeling application. For example, let's suppose that you want to apply a dissolve effect from one end to this model to the other. For this, we have used a transformation matrix and the world space, but you can also do it in a very simple way using a second UV channel in Blender. You project it from the top view, and just like that, you make a transition from 0 to 1 in the Y coordinate in a GODOT shader using the second UV map, or you can arrange it as you want to achieve complex effects. To show the different spaces, I'm going to use this texture in order to demonstrate the mapping in detail. In addition, I am going to show different materials with a very similar structure. Starting with the local space, you have to understand that there are coordinate systems that have 3 dimensions and texture loading is done in 2 coordinates. So I'm going to use a simple shader that has some parameters to adjust the coordinates. It uses the local space, and I am using this switch structure to toggle between XY, XZ and CY planes. Then I use that plane to load a texture in the object. Here are the shader parameters. They are at the bottom in the instance shader parameter section. It has these very strange checkboxes that seem to show up because I have defined a default value. In XYZ, I can toggle between the different planes. For example, here the X and Z. I can also alter the scale. And finally, I can move the texture on the 3 different axes, X and Z in this example. What makes local space unique is that I can move or rotate the object, and the texture moves along with it. It looks like the UV space, but it's not really. The world space is very similar to the local space. The difference is that when we move or rotate the object, the coordinates remain static. For this reason, world space is very useful for a lot of effects. The view space is the most difficult to handle, I think. In the fragment section, the vertices come by default in this coordinate space. The Z coordinate represents the distance from the object to the camera. Here, the different planes are no longer useful, only the XY plane is relevant. The transformation to clip space is a bit different from the others. We get here a 4 value, the W coordinate. It is used to make the division of the XYZ coordinates. Visually, there is no difference between clip space and view space. It looks exactly the same. Finally, we have the screen space. You might notice that the screen space corresponds to the coordinates of the viewport. By making the division between the W value and correcting the size and negative coordinates, we obtain the screen space. We can obtain the complete transformation for free using the screen UV coordinates. This is quite useful. This is where the screen buffer is applied. Besides, we can create very interesting effects in this space.